You probably use a search bar, dozens of times a day? But if you ever stop to think about what's actually happening in that tiny little sliver of time, that split second between you typing a question and getting a whole list of answers? Well, today we're going to pull back the curtain on the incredible, secret journey your search query takes. All right, let's get into it.
I mean, seriously, think about it for a second. You hit enter, and faster than you can blink, some system somewhere sorts through literally billions of websites to find exactly what you're looking for. It really does feel like magic, right? But it's not magic. It's a brilliant field of science. And that science has a name. It's called Information Retrieval, or just IR for short. At its core, IR is all about the messy stuff. It's the process of sifting through these massive piles of unstructured data, things like text, documents, entire websites, to find information that isn't just an exact match, but is actually relevant to what you asked.
Now, to really get what IR is, you got to separate it from its much neater cousin, data retrieval. See, data retrieval is for clean, organized, structured data. Think of a database table. You ask a precise question like, find this student's marks, and you get one exact answer back. But information retrieval, that dives into the chaos of human language. When you search for something like uses of AI, there's no single correct answer. The goal is to find the most useful and related stuff out there. And trust me, that is a much harder problem to solve.
So how in the world does it work? Well, your query goes on a little journey with 5 main stops. First, you ask the question. Then, the system has to process it to figure out what you really mean. After that, it searches for documents, ranks them from best to worst, and finally shows you the results. We're going to walk through every single one of these steps.
Okay, let's start at the very beginning, understanding your question. Before a computer can even think about finding anything, it first has to translate our kind of messy, human way of talking into something logical and consistent that it can actually work with. A huge part of this is a process called conflation, and the idea here is actually pretty simple. The words connect, connecting, and connection, they all point back to the same core idea, right? So conflation is just the process of grouping them all together under one common root. That way, if you search for one, the system is smart enough to know you're probably interested in the others too. Now, there are 2 main ways to do this. The first is called stemming. This is kind of the fast and dirty method. It just chops the end off a word. It works sometimes, but it can be really inaccurate. See how easily becomes ease? That's not even a word. Lemmatization, on the other hand, is much smarter. It is a bit slower, yeah, but that's because it uses a dictionary to find the actual root of the word. So it knows that the root of better isn't bet, it's good. Pretty clever. All right, so now the system has processed our query. It knows the core concepts we're looking for. The next question is, how does it search through billions of documents in a fraction of a second to find them?
Well, here's the thing. A search engine can't possibly read every single document every time you hit search. That would be insanely slow. The secret is that it does all the hard work ahead of time by creating a very special kind of index. And this right here, this is it, the inverted index. This is the secret weapon of basically every modern search engine. Just look at how it works. Instead of a list of documents and all the words inside them, it's flipped. It's a list of words, and for each word, it points directly to every document that contains it. So if you search for retrieval, the system doesn't have to scan anything. It just looks up retrieval in the index, and boom, it instantly knows to check Doc 1 and Doc 2. It is incredibly efficient. So now the system has a list of documents that have our keywords. But that's not good enough, right? A search for artificial intelligence could give you millions of pages. The real magic isn't just finding them, it's getting the most relevant, the highest quality pages right to the top of the list. And that is where ranking comes in. The main idea behind ranking is something called index term weighting. Essentially, the system gives every single word a numerical score to figure out how important it is. Because not all words are created equal, right? In an article about AI, the word artificial is way, way more important than the word the. Term weighting is just how the system figures that out using math. The most popular way to do this is called TF-IDF, and it's got 2 parts. The first part is term frequency, or TF, and this one is super intuitive. It just asks,
How many times does a word show up in one particular document? If a document mentions the word robotics 20 times, it's a pretty safe bet that robotics is an important topic in that document. Simple as that. The second part is inverse document frequency, or IDF, and this is where things get really clever. IDF asks the total opposite question. How rare is this word across the entire collection of documents? So super common words like is or and, they're going to be everywhere, so they get a very low IDF score. But a rare specific word, like say exoplanet, well, that gets a high IDF score because it's a powerful signal about what a document is specifically about. Now, when you multiply the TF and the IDF together, you get the magic formula. The highest scores go to the terms that are used a lot in one specific document, but are rare everywhere else. And that turns out to be the perfect mathematical signature of a key term that uniquely describes what a document is all about.
Okay, so what does the system do with all these scores? It uses them to build something called the vector space model. Now, this sounds super complex, but the idea behind it is actually beautiful. Just imagine representing every single document and your query as a single point on a giant multi-dimensional map. Each direction on this map, each dimension, corresponds to a unique word. And once you have this incredible map of concepts, the solution for ranking is surprisingly elegant. The documents whose points on the map are closest to your query's point are considered the most relevant. It basically turns the fuzzy problem of language into a straightforward geometry problem. Just measure the distance. It's a brilliant, brilliant way to rank results.
So, the system has given us a ranked list of results. But the journey's not over yet. How do we even know if the search was any good? And, maybe more importantly, how does the system learn from its mistakes and get smarter for the next time you search? Well, to measure success, we generally use two key metrics: precision and recall. Precision asks, of all the results I'm looking at, how many were actually useful? So high precision means less junk on the page. Recall, on the other hand, asks, of all the useful documents that exist out there in the world, how many did the system actually manage to find for me? High recall means you're missing fewer of those hidden gems. And there's usually a trade-off. A perfect system has to find a balance between both. And how does the system learn? Well, one of the classic ways is with something called relevance feedback, using an algorithm called Rocchio's algorithm. And this is a method where the system actually uses your behavior, the links you click on, the ones you ignore, to refine its own understanding of what you actually want.
Here's how it works. When you click on a result, you're essentially telling the system, yep, this is relevant. And if you ignore a result, you're kind of saying, nope, not relevant. The algorithm takes that feedback and literally modifies that query vector we were just talking about. It actually nudges the query's position on that giant map, moving it a little closer to the good results and a little further away from the bad ones. So the next time you search, it's even better. You're constantly training the machine without even realizing it.
And there you have it, the query's journey complete. Your language was understood and decoded. Potential matches were instantly located thanks to the inverted index. All the words were scored for importance using TF-IDF, then ranked on a vast map of concepts. And finally, the system refined itself by learning from your choices. Ready for next time.
It is an absolutely incredible process. All that complexity, the decoding, the indexing, the weighting, the ranking, and the learning, it all happens in the time it takes you to hit enter and for the results to pop up on your screen. A whole universe of computation hidden behind a simple blinking cursor. And that kind of leaves us with one final thought to chew on. We've seen how these systems work so hard to give us exactly what they think we're looking for. But as they get better and better at predicting our intent, how does that amazing efficiency start to shape the information that we end up discovering? What happens to those happy accidents, the unexpected finds? It's something to think about. Thanks for joining me on The Explainer.